Forest issues nowadays are transnational, so to tackle them, we need really good forest information across countries, at least for the whole of Europe, perhaps globally. So what we are trying to achieve with our research is to facilitate that we can have reliable information for several countries that we can use to make better informed decisions in policy making. My name is Rubén Valbuena and I am a professor of forest remote sensing. In remote sensing, we get information of the forest at a distance, and that distance is usually satellites, or it can be with airborne sensors. Nowadays, it's also typically with drones. It can also be information we actually get in the forest, but always with sensors at a distance. This information can give us a lot of advantages because it can give a landscape scale and also a higher temporal recurrence, so we can have more timely information on the forest. But it also comes with problems because it's not the forest itself, so we lose a bit of touch with the forest, and our research is mainly on trying to find the best combinations of field information with remote sensing information. Climate change is putting our forests in danger, and the loss of forests is also bringing a dramatic loss in biodiversity. What motivates me is to help the forest and help the species living in them, and of course the people who live off the forest and thrive in it.
Welcome again.
Thank you.
When you describe what you technically do in your research, you say that you fire laser beams. What does it actually mean to fire laser beams?
Yeah, we do a bit like in Star Wars.
Okay, Star Wars, yeah. Okay.
Yeah, but our lasers are not so powerful. We're not gonna destroy the Millennium Falcon or the Death Star. What we actually do is we detect the same laser as it bounces back from the surfaces where it hits. So we measure the distances.
Okay.
And we do that at very, very high frequencies, very fast frequencies, like 200,000-300,000 pulses per second. So we get these huge point clouds of all the information that is inside the forest, and it's about putting it into use.
Okay. And what has laser been used for up to now when it comes to remote sensing and forests?
Well, what is wonderful of these lasers is that as it reaches the upper part of the canopy, it passes through and it reaches the ground. It gives us information of what is in the ground and all the vegetation of the biomass that is within the entire vertical profile. So that gives us an advantage over satellite images that maybe only detect changes in the forest once the whole thing, or almost all the upper trees have been cleared.
Okay.
So it's also the best way to measure tree heights, better than trying from the field in itself, and we do it for entire landscapes. So we have this team at SLU Remote Sensing who uses this laser technology to make these maps that are covering the entire country.
Okay. And how old is this technique with laser beam firing?
A couple of decades ago,
Okay.
maybe 3.
Okay. And what is the potential, would you say?
Well, the potential, I think that the bottom line is in the autonomous vehicles, on vehicles, drones and other vehicles that, whether we like it or not, very soon we're going to be surrounded by these machines finding their way around us. And I mean, most of us already have at home a vacuum cleaner or a lawn mower, which is finding its own way. And the technology these machines are using are exactly the same. It's a LiDAR, or it's stereo photographs, or a combination of those. So once those machines start finding their way through the forest, and the limitation right now is just on batteries in that sense.
And maybe legislation?
Maybe
legislation as well, rules?
Well, yeah.
No, more battery. Okay.
Yeah, also legislation, partly, only partly. So
Okay.
they will soon start finding their way through the forest, and so it's about gathering all that information and put it on the best use for our forest.
Okay, you will tell us more about how to use this information. So please prepare for your lecture.
Thank you.
And I would like to introduce Rubén Valbuena, who is going to talk about measuring the complexity of forests by firing laser beams from planes and satellites. So the stage is yours.
Thank you very much. If you can make sure that my presentation shows in there, please. Well, this is what we do. We measuring the complexity of forests by firing laser beams in our planes, from planes and satellites. So why we do this? We all been speaking of carbon sequestration, and that holds true also for these technologies. But I want to pay the attention on the fact that we are also facing a biodiversity crisis. We are it's a loss of biodiversity crisis. That's the problem. According to IPBES, 25% of species on Earth are threatened with extinction. And this is also this is happening because of the loss of habitats. We having natural ecosystems have declined 47% on average. So because of that, the COP15, the Conference of Parties of the Convention of Biological Diversity, met in Montreal. I was lucky enough to be in there. And the Kunming-Montreal agreements were signed. That is a global biodiversity monitoring framework. Some targets, some goals that we want to reach to help stopping this biodiversity loss. So what we need to do that is a global biodiversity observing system. And what I am working in is helping this Earth observation information to be put into correct use for that. So in particular, this 3D imaging information can be used, and they are for use to inform these global conservation policies. So we're doing the work that we need to do for the entire world. That's more difficult. It's different than making decisions at a local, regional, or even national level. This is for the entire world. So what we need to do is go to the very, very basics, and that's what we call the essential biodiversity variables. And the ones that I am working in particular are these, are the basic, very, very basic properties of forests, of ecosystems that we can try to characterize and deliver products that can be for the entire forest, for the entire world. So in particular, my work has been very focused on this last one, on the structural complexity. So what we're trying to do is trying to differentiate in what type of forest we are, whether it's monocultures, forests where all the trees are of one same size, one same age, or if we are in this type of forest that would contain within trees of several different sizes. You could argue this could be perhaps more favorable for biodiversity if it creates several niches from which different species can thrive. So the technique that I chose to employ to do this is called the Gini index, and this before I started using it, it had nothing to do with forest science. It's used in econometrics. This is a map of the Gini index of the world income. So let's say that some countries, like Sweden, is relatively rich, but also the society is very egalitarian. More or less all the members of the society have a same level of wealth. Other countries are rich, like the United States. It's a lot of money, but then there is a lot of inequality. Most of the money is in the hands of few, and then there is a lot of people who don't have that much money. Or the other way around, then there are countries that are not as rich as the United States, but it's still a more egalitarian society, like it can be Algeria, India, or Indonesia, for example. So this Gini index is based on a method called the Lorenz curve, which is based on ranking the individuals of the society by the level of income that they have, and that is with respect to the total share of the gross national product. So that Gini index that I was showing before is the area that this curve makes between that curve and this diagonal. This is the level of total equality if all the members of the society have exactly the same money. So my work, what I was basically pioneering was to develop the same methods but applied to forest science, to forest ecology, and to remote sensing. But in forest science in particular, what we do use is a very similar logic, but in this case what we rank is the trees according to their size and according to the share of the total forest volume in the forest that they have. And it gives us that key, whether they are all the same size or they are different in sizes. So then we use this technology. We fire the lasers from satellites, from airborne, nowadays also from drones. And the trick is in developing products, global products, for which the platform of the sensor that we use wouldn't depend. We're doing the same thing. So we generally get, from these lasers, as they hit the forest, we get a whole vertical profile. We get information of what is the upper canopy, and they reach the ground, and they give us information about the terrain underneath and all the levels of biomass apportioning that can be along the entire vertical profile. So that's the work, trying to make simple, concise metrics that can be developed for the whole of the world with these essential biodiversity variables that I was talking about. So I have an example in here of work that we were doing in the Brazilian Amazon. This is from this satellite LiDAR that is called JEDI, and we were combining with airborne laser scanning in here with those lasers from airplanes, trying to see that we can develop the same metrics. But in this case in particular, using the satellite laser, we could see that this is a typical satellite image, and this is how deforestation is usually identified very easily. But the guys who do illegal logging, they know that already. They know we can see them with the satellite images. So they may go and try to get trees from underneath the dominant canopy. And we could see a bit of that. We could see with this JEDI that there may be areas where we cannot see anything otherwise, and actually we are detecting something with the laser, that something is changing in the ecosystem in there. And another good example is also these forest maps that I was explaining before about for the whole Sweden. We already have covered with this technology from airplanes for the entire country twice. And our team develops these forest maps in there, and we're trying to develop all these indicators that these maps can be exactly the same that we can use from these satellites. So this is my presentation, and this is just a last slide about one of the last projects that we are now starting, this next-gen carbon, and it shows a very, very, very precise model of the International Space Station, and this is exactly that laser that is mounted in there. Thank you very much.
That's cool. Thank you very much for a very interesting lecture. And I'm curious about how you came up with the idea to use econometrics to measure the complexity of forests.
Yeah, well, I wasn't. It was just the mathematics of it. They took me there.
Okay.
There was this morning. I was maybe inspired. This morning I woke up at 4 a.m. one day, and then I was going to quickly grab pen and paper to write down all the math because I was having this problem for several weeks and in my mind, and then that morning just click in. So I wrote it down, and it's a bit complex to explain, but what most people who are trying to do something about forest structure with this technology, they are using something that is called, they are making an artificial partitioning of layers in that vertical profile that I was showing before. And then they are calculating an index from MacArthur that is called foliage high diversity. And so I thought that it's wrong to do this, already call it artificial partitioning, So I was gathering evidence of why doing that would be wrong. So for that I was looking at these curves. This is called, they are the ranks abundance vectors. And I was looking how they behave, how you can compare or not two populations with them. And the math just took me, it really was like, well, instead of apportioning, you can just rank the trees themselves by size, and there you have it. So then that was like, oh, well, look at that, that's Lorentz curve, by the way. Okay, so then I started deepening and looking at all kinds of how you can look at different parts of that Lorentz curve, not just the Gini coefficient, and make applications to forest science, forest ecology, remote sensing.
And what does your colleagues studying economy say about what are their reflections on your way of using their findings?
I never ask.
You haven't? Okay.
I never ask. I don't think I give anything added to their field. I can look at their
Not
field
yet.
and still not yet.
Well, you're welcome with your questions, of course, and also those of you participating online can send your questions to nyaprofessorer@slu.se. Please.
Yes, thank you, Ruben. Very interesting in an area that is developing very fast nowadays. My question for you is, how much and in what detail will we be able to detect with remote sensing in the future? Will field inventories and species expertise be needed at all in the future?
Can you say again, with field inventory?
Will we need field inventories and species expertise, or can we solve this with remote sensing in the future?
No, it's very important that we always keep the touch with the ground. Remote sensing is great, but especially validating what we are doing is important to always get some information, have a look how things are actually on the ground, and make a really good comparison to evaluate the reliability of what we are doing. Yeah, that's very important.
Yes.
This brings me back to memory as a young student when we made a field study testing the hypothesis of MacArthur in 1974, I think, this publication, where they showed there was a correlation between biodiversity and the structure of the forest.
Exactly.
Does it still hold this old result, or did you find anything new in that relationship?
I think that the answer is no. When I started working on this, it felt a bit like Galileo, meaning that you're really trying to say, and still foliage high diversity does not work. I was lucky enough to get to know Tom Lovejoy in person, and I spoke with him, and immediately after MacArthur was finding that in North America, he was not finding it in the forest fragment experiment in the Amazon. He was failing to find anything. And having a PhD student now in SLU that is doing a really good job in improving this, how some of the previous within some of the previous metrics that have been used are spurious, and they are impeding that we actually find relationships with biodiversity that hopefully we may start finding now if we are getting better metrics.
Well, I was wondering something completely different, which is how your research can support decision making in EU, for example. It's a big question, but can you just give a.
Well, no,
I know you work a lot
it's
with.
a very important, and forest is very high in the political agenda at this moment, and the EU agenda in particular. And I think that is a really, really good thing. I take it as a duty to help politicians and decision makers to make really good legislation, really good decision making. Remote sensing, like I've been answering to Pernilla before, is really good. It can give us really, really, really great information about the forest, but it can also be misused. There is a very high danger of it being misused because different people may interpret it a bit differently. So it's very important to liaise closely with the Commission, the politicians, also the government of Sweden, to help them make really correct use of that information. So right now we are having, forest monitoring law, nature restoration law, carbon removal and carbon farming. We really are having a lot, and remote sensing can help us finding how forest is sequestering carbon in the large scale. It can help us seeing how forest growth and productivity is happening. It can help us detecting threats and analyzing how the forests are, again, at the large scale changing with climate change. I think it's very important that remote sensing gets at the core of all this policy making. So we move into forest monitoring systems for the 21st century.
So it's of great importance. Yes.
I have a short question.
Yes.
Can this technology be used to make measurements or surveys in lakes and oceans for algal bloom, for instance, or structures underwater?
So the answer is yes and no, meaning that we can use similar technologies, but not exactly the same one. I can be very specific. Those lasers that we fire, they are near infrared. That's what gives us the best information. But that is very low intensity wavelength. So when it reaches the water, it gets absorbed immediately. So, but there are lasers of stronger wavelengths. The green, for example, can go a bit deeper and are used to study riverbeds. And then there are also other technologies like stereophotogrammetry that may be a lot better for the bottoms, for the benthic areas, for the bottoms of the ocean. And indeed, when we are developing these essential biodiversity variables, are about doing variables that are the same, should be same valid for terrestrial and ocean. So I think we can do that, but there is a challenge in doing that.
So yes and no. I understand you are coordinating 2 EU Horizon projects and you're participating in many more. And one of those you could coordinate is called Forwards and the other Next Gen Carbon. Could you say something about the main objectives of these projects?
Thank you. In Forwards we are developing a prototype of an observatory to secure the resilience of European forest. So what we're doing is developing a network of tree instrumentation. Like I was answering before, always with the hand in the forest. This tree instrumentation is subflow, is water availability, is the growth of the trees. So why we got that is because within from few trees we can get information, very, very prompt information when the stress is just happening. Then we can use remote sensing to make a prediction of, okay, what these few trees are telling us in here, it may be affecting all these areas of forest. So that's one part of what we are doing. Then we are also trying to link all that information with forest management guidelines and also having a look at the societal perspectives the perspectives of the society towards those management practices, because that's another thing we shouldn't lose touch with the people. That's and then there is next-gen carbon, and next-gen carbon is the one that I was showing before. Is a newer one. In that one, we are incorporating the Earth observation into the most advanced models of carbon fluxes with the atmosphere in the Earth. And also with those that make the counts for the IPCC. So that satellite LiDAR that I was showing from the International Space Station is one of them. It's one that can help us, this work can help us clarify whether that forest structure that I've been explaining actually have what effects have in the overall carbon sequestration.
Well, sounds like very large or big projects. And what does it mean for a university to host a EU Horizon project?
Yeah, it's an opportunity. It's an opportunity for everyone. It's a great opportunity. So SLU researchers can display their work in these projects and put it at the best outreach. Put it in the European context, link with the world-class researchers in these fields. In the remote sensing division, there are 30, 40 people. So they are the ones who do the actual work. That's so for me, my job, the way I see it, is to give them the opportunity to put that work into the highest, the outreach of the highest impact possible. That's and then there is another effect, and is that also I see the European Commission and other important players are paying attention to what we are doing. They see us as leaders, and they start calling us for us to give our opinion about the matters that they are doing. So it has that double effect. It's an opportunity for everyone.
Oh, so good luck with coordinating those important projects, and many thanks for your lecture and for joining us.
Thanks to
Thank you.
Thanks everyone.